Hello everyone, I hope all of you are doing well and safe. From today we continue teaching in an online manner. If you remember, we were talking about programming languages or programming models for distributed systems. We introduced two main categories, message passing and shared memory. So in the message passing category, we talked already about sockets, and now we are going to talk about shared memory category and thread programming within that category. So, you know the structure of a program. It's a sequence of instructions. A conventional program is nothing but running these instructions sequentially. However, in a thread program, the structure is a little bit different. We have one main big process you can imagine, and within that, we have multiple processes. So, multiple sub-processes, better to say. Let me see if I can draw that. So you can imagine this as a big process, and within that we have multiple threads. So each thread, as I said, is a sub-process, has its own execution state, has its own private variables. However, in addition to that, it has access to some shared resources. So these resources are for the process. So this is the process level, and these are the threads. So you can say this is a thread. So, and they have access to these shared resources that are allocated to the process. What do I mean by shared resources? The best example could be the memory. So basically the memory is shared, or RAM, by memory I mean RAM. RAM is shared between all threads of a process. All right? So, so basically, via that shared memory, these threads can communicate. So in other words, unlike sockets in which the communication was through, by passing messages between two processes, in this case, we have the communication happening through RAM. So basically, all of these guys have access to shared memory, and if one thread wants to talk to another one, just writes a message here, and this other one can read the message from there. So that's one style of communication. So I guess I talked about this one. This is the common address space, which means essentially the common resources, the shared resources, and then we have multiple processes. There are multiple applications of threads. Many applications nowadays are thread-based. One of them that we have already talked about is in client-server applications. So basically, each client, let's assume your web server. Let's say you connect to a university website and you want to see your grades. So you open your browser, and then your browser, you can imagine it as a single thread, and then that you log into your account on the university website, and then one thread is created for you, and then all your interactions will happen through this thread. If your friend at the same time wants to view his or her grades, another thread is built for him or her. And then you guys can communicate independently with the same program on the server. Well, this case was pretty much a scenario where the threads are independent from each other. But it's not always like that. I will give you examples where this is not the case. But before that, let's see some more applications of threads. As I said, we can rarely find applications nowadays that are not thread-based. For example, Microsoft Word that all of us are familiar with, or PowerPoint that I'm using in these slides, are all thread-based applications. For example, once you are typing into a Word document, another program concurrently, another thread concurrently is catching your syntax errors. So that's a thread. Another program, or another thread, better to say, is taking care of the print operation while you are typing in your computer. So that's another thread. They do not interfere with each other. They just work at the same time from one process, being Microsoft Word. All right, so there are other applications for threads that are more at the system level. For example, when you want to copy some data from a peripheral device, from a storage, from an auxiliary storage, let's say from a disk or from flash memory into your hard drive. So that is a multi-thread, as that's an example of multi-threaded application. In other words, there are two threads. One writer thread, whose job is to read data from the source disk and copy it into memory. And then another thread, whose job is to read from memory and copy the data into the destination disk. So these two operations happen simultaneously, or in other words, these two threads run together to do the copy operation in a more efficient manner. We note that this example of thread-based programming requires some arrangement, or more specifically speaking, some synchronization between the writer or producer and reader or consumer applications or threads. In other words, the reader applications cannot read from the buffer. Buffer is like a RAM, right? So it cannot read from RAM or from the buffer when it is empty. So it has to wait. It has to synchronize itself with the writer operation. So that being said, we know that threads sometimes, not always, need to do some coordination, some synchronization to be able to do their job in the right way. There are numerous examples that need synchronization. What I just explained is called a producer-consumer example. There are other examples too that I will mention in the next slides. Now, next question is how to program threads, or how to do thread-based programming. Different programming languages have facilities for thread programming. In Java, for example, within Java, there are multiple ways of doing writing thread-based programs. One way is to extend the thread class. So extending the thread class. So it has a run function. Within that, you write the code that you want to be run concurrently. In other words, whatever you write here, when you launch your thread, this code will be executed. So once you develop your thread class, then you instantiate from that. So here is the instantiation. And then once you instantiate, you can call that thread program. Note that calling, although the function name here is run, here we call it with its start function. That is strange. That's a strange behavior of Java, that you need to call start function, but when you do that, in fact, you are invoking this run function. So you should be aware of this. Well, here is another example, a more practical example. Again, we extend the thread class. There are other ways to do so, but this is just one way. Then you implement the run function, which is, in this case, very simple print function that you are all familiar with. And then this is our main class, main function. You instantiate from this myThread class, and then you do this start, which runs this run program. All right, so this is how you do thread programming, and then we also talked about some applications of threads. I'm not going to explain in details how to do thread programming. This is beyond the scope of this class. In the operating system course, you will extensively taught about thread programming. Okay. However, I just want to remind you that we need synchronization between threads if they want to access some shared data, specifically if they want to write on a shared data. For example, you can assume that two threads from two processes, or even one process, doesn't matter in this case, want to print at the same time. So printer here is the shared device. Well, here is not the memory, but it's a device, doesn't matter. So these two threads, if there is no synchronization in place and they just both want to print at the same time, we can imagine that they will print some nonsense stuff. Basically, they mix up the texts, hypothetically, if that happens. However, this printer is protected against shared access. There are some other examples, even some more dangerous ones, like, for example, your bank account. So if your bank account wants to be accessed by multiple threads at the same time, then the result would be inconsistent, right? So suppose that you are depositing, or someone is depositing money into your account, and at the same time, you withdraw some money from your account. So the balance variable, if you will, is access. That's a shared variable between deposit and withdraw functions, right? So this variable is accessed simultaneously, and if it is not protected, one may, we don't know which process is doing the things first, and if they do things very simultaneously, it is likely that you end up with an inconsistent value for your balance. So these things you should be careful. So, but there are many solutions for this, managing these shared resources, the shared memory, more specifically speaking. One is known as synchronization, or another technical term for it is known as monitor. Again, I'm not going to explain these methods in details. This is one of the main topics of your operating system course. However, in Java, very briefly speaking, we have a synchronized keyword that you can apply on your function, and then once you apply that, it would be thread-based, thread-safe, which means that if thread A starts running this function, thread B wants to access this function, it is blocked until function A is done with, thread A is done with this function, exits this function, and then the next one is allowed to start execution, right? So, so this is what synchronized keyword does in Java, and it's known as a monitor technique in handling shared memory. All right. So again, we can skip these slides. Don't worry, these are not important topics for your exam, but you just should know about them. All right, so I guess I talked about multi-threaded server, so I can basically skip this slide. This is another example, kind of homework that you can do for your for thread programming. For example, in this example, we want you to implement a math server where different users can connect and request different mathematical operations. So this is a very basic example of thread programming. All right.